We can look at geography together. We can look at volcanoes together. Great.
Hey, you lovely lot. I'm Teacher Jess, and welcome back to Geo Cafe. So, I noticed that Mount Etna has been in the news recently, and I thought that would be a good opportunity for us to take a look at volcanoes and what they are, and then we can have a little look at what has been happening with Mount Etna and that eruption. Let's check it out. So let's first take a look at where volcanoes actually form. So volcanoes generally form along the plate boundaries. Over here we can see the plate, and along those boundaries where you've got one plate colliding with another plate. So here we'll have a continental plate and here we have oceanic plate. And where they're colliding together, you see all types of activity over there, like the volcanic activity or earthquakes. All of these little triangles over here, these little black triangles, that is where we have recent volcanic activity. And then the little red dots are your earthquakes. And what basically happens is where you have these plate boundaries, you have your dense oceanic crust that is slowly subducting under the lighter continental crust, and that starts to melt when it's pressed into the mantle. And all of that molten rock will basically bubble up to the crust and it will push through the crust wherever it can find a weakness, and it will erupt or be released to the surface through the form of a volcano. They can also form where we have hotspots. So that's not necessarily on a plate boundary, but it could appear like it's in the middle of the plate itself. So you can see them over here. There. This is the plate boundary. There. Then there we have a few volcanoes that have formed. Now there are two different types of volcanoes. The one is a fissure volcano, which basically happens where you've got these cracks in the surface or these cracks in the crust, and the lava slowly creeps out through these little cracks and fissures, but you won't have a massive eruption like what we would think of when we think of a volcano. And you get this layer of solidified lava, and we actually have a lot of interesting landform features that occur because of this, like on plateaus. A lot of plateaus are formed having a layer of very resistant igneous rock and then softer layers of rock underneath, and that is how this would form. You would have this slow, very thin movement of lava over the earth, and it would spread quite fast, so it would spread over a big area, and it would create this solid layer or solid crust over the softer rock. And then the other one is more a volcano that we actually know, the central volcano, so where you've got a central pipe that goes through the cone of the volcano. So here is your cone, and going through the middle, we've got the pipe that carries the lava to the surface, and then we have a eruption of some type. We've got lava going everywhere and ash going everywhere, and all kinds of interesting and exciting things. And in terms of activity, we classify them using three different groups. So the one is active. Active means that the volcano has been erupting regularly. Dormant is basically it's just having a long nap. It hasn't erupted for quite a long time, a few hundred years or so. It doesn't really look like it's going to erupt, but it could. And then extinct is basically has not erupted for thousands of years and does not look like it would ever erupt again. Then we get to volcano shapes. Volcano shapes are generally formed by what is coming out of the volcano. We've got four main categories or four main shapes that I'm going to go through, and they all come down to, is it lava? Is it ash? Is it a combination? And how these things are projected when it erupts will influence how the volcano is formed. So the first one that we're going to take a look at is the shield volcano. The shield volcano is quite a wide volcano. There are some of the largest volcanoes, but they are known for being very flat. And the way that they form is through lava eruptions, and the lava will be quite thin, so it will be very runny. And because it's thin and runny, it will spread very far. And it won't necessarily have very big or very violent eruptions. It will just be trickling out the whole time and spreading quite far. And that's why you get these very wide, very thin layers to the shield volcano. The lava dome is also formed by the lava slowly oozing out of the volcano, but the consistency or the viscosity of the lava is different. So in the shield volcano, the lava is very thin and it can spread very far, but with the lava dome, the lava is quite thick, it's quite viscous. So it doesn't flow very far and it kind of just bulges over itself and it solidifies in this bulb type of shape. So these two volcanoes, very similar in the way that they don't have very big eruptions, they're both just formed by this slow trickling of lava. It's the viscosity of the lava that influences the shape of the volcano. Okay, and then we get to the cinder cone volcano. So cinder cone volcano, unlike the previous two, is more derived or more made of ash. Ash and cinders and tiny little fragments of lava that have solidified. These volcanoes tend to have very big eruptions. When they erupt, there's a lot of ash and gas and everything going everywhere. Very explosive eruptions. And these are a lot taller and majority made up of ash and cinders. And then that brings us to composite volcanoes. Composite volcanoes are also sometimes referred to as the stratovolcanoes. Unlike the previous ones where it was either made of lava or ash, the composite volcano is made up of varying layers of both. The reason why it's also called the stratovolcano is because strato means layer. So it is layers of different types of materials. Depending on the type of eruption, if it's quite a quiet eruption, then it will be mostly lava that comes out. It will cover the cone in lava. And if it's quite a big eruption, it will be a majority ash and lava as well. And that will cause a layer of ash to form. Okay, so this was just supposed to be a nice picture of a composite volcano, but I'll see if we can find something better, especially when we look at our case study. Okay, the structure of the volcano. So even though volcanoes come in all different shapes and sizes, they still have a very similar general structure. A vent is a pipe that will go through the volcano to the surface. See over there or over there. The cone is the general structure, like or I don't want to say it's the sides, it's basically the pieces that keep it all together. So yes, it's the sides, it's the parts that come up, that is the cone that's encompassing everything that's happening inside. The magma chambers are deep within the actual volcano. That is where the magma builds up, and then when it erupts, we call it lava. And then the crater is the top, that is the hollow where your major eruption will come from, or you'll actually see it as a crater when nothing is happening. And then one of the interesting landform features that we get from volcanoes is the caldera. That basically happens when a volcano erupts to the point that it collapses in onto itself. If you imagine lava is busy building up, okay, you can't really get it from this diagram, but if the lava is busy building up and it solidifies and it's building up pressure, eventually when it does erupt, it erupts to the point that it breaks and completely destroys the cone that's over it. So over here, if this all breaks down or weakens in its structure, then that can cause the volcano to collapse in onto itself, like what we see over here. So this was the magma chamber over here. We've got this release of eruption all around wherever these weaknesses, and the volcano and the cone has collapsed down into the magma chamber. And that's where you have this crater, this caldera left behind. And over time, that can also either form a new volcano, or it would fill up with water and you end up with a lake. There we go. So here you can kind of see how we had this volcano cone around the sides, and then the middle collapsed in onto itself. And here you can see some new little pipes forming and little volcanoes trying to restore themselves. And here you can see the nice picture of what it would look like if it was filled with water and makes a lake. Okay, now volcanoes are not just interesting topics in geography. They are also massive forces of nature, but they're not always bad forces of nature. They can have a lot of positive impacts in our lives as well. There's a reason why there are a lot of settlements around volcanoes, but there is a cost to living near a volcano, and that's the negatives. Okay, so let's just first look at why people would want to live in volcanic areas or why we find settlements over there. And one of the main ones is that the lava and the ash can actually contribute to nutrients and minerals in the soil. So once that lava and the ash weathers away, it can leave or produce very fertile soil. So it's good for farming, it's good for agriculture. The rock itself can be very good for any type of building, another great natural resource. And the heat from maybe springs can be used to produce electricity. We typically find a lot of minerals and valuable stones in or around volcanoes, diamonds being a nice example. And of course, people are generally fascinated by volcanoes and would like to go see them or visit them, making it a nice tourist destination. But there are downsides. One is that the ash and the cinder itself is very dangerous. I'm actually not sure why I didn't add lava into that as well. Basically, anything coming out of the volcano is dangerous, and people can be hurt and lives can be lost. If you have settled around the volcano and you are using the lands for farming because it's fertile, it does mean that that can also be destroyed if there is another eruption that covers it with new ash or new lava. So you can have a lot of farmlands and settlements become or be destroyed. Air pollution that can come from all of those gases and the sulfur released into the atmosphere. You can have acid rain and all types of harmful chemicals that people can inhale. It can also impact the global temperatures. If we have a lot of ash in the atmosphere, it can block sunlight from coming in, and you can get something of a global cooling for a period of time. Ash will obviously interrupt day-to-day lives like air travel or other types of transport. So I've got an interesting article that I want to take a look at. The ash buildup in the clouds can block air travel. Lava can destroy all type of infrastructure, and it can also lead to secondary disasters. I liked this description where they were talking about a eruption can maybe cause some type of snow melt or permafrost to melt, so it can trigger some kind of mud flow or flooding. And then if there is any kind of an area that has been covered by lava, it typically can't be used for many years afterwards because it's such a hard rock. Now, since we've run through the essentials of what volcanoes are and how they form and all of those lovely details, I want to take a look at a few case studies. And I came across this article from, I think it was a couple of days ago. I don't know how reputable this site is, the Japan News, but I thought this was a very interesting article and I wanted to go through it. In this article, they were talking about what Japan would have to do to prepare for a massive eruption. So they mentioned Mount Fuji over here, but that's not the only volcano that they're, concerned about. There are so many volcanoes in Japan, and they are thinking, what do we do? Even though we haven't had a serious eruption in quite a while, we still need to plan for if or when something like that happens. So one of the main focus points of this article is what do they do with massive ash buildup? With big eruptions, the lava obviously is, one major concern, but the real more far-reaching impact is the ash. And in this article, they were looking at what they would do with different levels of ash. They were talking about what would happen. So they're saying over here, in 2 weeks, ashfall could reach 30 centimeters or more. And they kind of use this as their threshold. So they say that if it's less than 30 centimeters, then people could basically continue their lives as normal. So they're saying 30 centimeters deep or less, and they can continue their daily lives or stay, just stay at home and be careful. There's no need for major intervention. But if it's more, then there is the risk of structural damage to the buildings. So they're saying that if there's more than 30 centimeters, then buildings, especially like wooden buildings, could actually collapse under the weight of the ash. And it's not just the ash itself, because the ash is actually fairly light, but it can hold a lot of moisture if there's rain. So the weight of the ash plus whatever water or rain it holds onto could be so heavy that it can cause buildings to collapse or other types of damage. So at this point, they would actually recommend that residents evacuate. The other point that they noticed is that it would actually conduct electricity very well if it was wet. So because the ash holds onto that water so well, it would conduct electricity quite easily, and it can cause all kinds of short circuits or power outages. And add that to the fact that there's a lot of communication and transport that is connected to the electricity, like railway lines, you would be cut off from communication and all forms or many forms of land transport. So railway lines would be completely cut off. That is the areas that they're actually looking to address. So they're saying that the industries that are based on electricity, communication, and railway lines should all prepare or plan how they can prepare in these types of events to basically make the infrastructure ash resistant. And of course, there is also the health concerns of the ash. So not only do they want to prepare the local towns and cities for the infrastructural damage, but they also want people to prepare for ash as its own threat with things like having goggles. I think they said here, protective goggles and dust masks, because the ash can actually contain glass. I mean, could you imagine getting ash glass in your eyes and lungs? And it just sounds like a bad idea. So that's why they recommend that people actually have goggles and dust masks in their earthquake or their emergency kits. So they're taking this potential risk and they're acknowledging it before it becomes a problem. Of course, all of this depends on what is happening in the atmosphere at the time. So the ash will travel as far and wide and in whatever direction the wind is blowing in. They have meteorologists that would also be studying the atmospheric conditions or the wind patterns at that time, and they will be able to advise how the ash could be moving or how far it could be spreading. So it's interesting to see how geology, in this case, volcanoes, can so closely connect to atmospheric science and meteorology, and how these two fields actually have to work together to try and care for and protect the people. And that brings me to Mount Etna. So Mount Etna was a volcanic eruption that happened fairly recently, I think like 2 days ago, so recently. And it is located in Italy over there. I don't know if you can see it on the map. There we go. There in Italy. The reason why we have these volcanoes here is because it is again on a plate boundary. You can actually see here's this line, this gray line with the little triangles, and it goes all the way around there and it doubles back to there. You have Italy and Europe, or the Eurasian plate over there. So there's Italy and there is the Eurasian plate. And these two are actually converging towards each other. And because of that, you have this little section of the African plate in between, which is, I believe, oceanic crust. And it's being subducted underneath these two plate boundaries. So we've got these two layers of continental crust converging together, and it's causing this section of the African plate to subduct underneath them. And that is what we have happening over here. And that is why we have this volcano. So Mount Etna, I believe Mount Etna is actually a stratovolcano. So let's just check. Yes, Mount Etna is a stratovolcano. So it's a composite volcano. It's made up of both lava and layers of ash and cinder. And as you can see, its eruption has definitely been news in the volcano world. So what they suspect happened is that a crater collapsed. They say the southeastern crater collapsed and that triggered this massive hot lava flow. It was the 14th eruptive phase in recent months. So yeah, it doesn't look like it was a singular big eruption, but more that it was one of multiple events that had been happening frequently. It does seem like the actual eruption and the lava that was released because of it was contained to that area. So it doesn't, they do seem to think that it's not a immediate danger to the population. So I'm actually curious to see if we can find a map of maybe where nearby settlements are and where the volcano erupted. But I think it was mostly documented by a lot of the tourists that were up there. Yeah, so loads of videos of tourists. They saw the eruption or they filmed the eruption and then you just had people running away. That's really cool imagery. Thermal imaging cameras show the Mount Etna eruption. So there you can actually see where all of the lava is coming out. I'm assuming you probably can't see that normally because of all of the ash and the dust and everything surrounding it. So you can't see where the lava is immediately coming out. When the gas bubbles reach the surface, they can burst suddenly, throwing material skywards. Well, it makes sense. So you've got all of these gases that are bubbling up inside the magma chamber and inside the volcano, and it slowly builds up with pressure until it is finally released, until it finds a weak point and it bursts through there. This is a really cool map. It's showing where lava has flowed before, if I'm understanding this correctly. Okay, so the gray area is urban areas. So we've got gray over there and here, here. Okay, so there's quite a bit of urban area around this volcano. So then all of these light pink areas around here, that would be, I'm assuming this is a year. So 1600s as in like the year, pre-1600 lavas. It would make sense then that we have all of these settlements in these areas, because if we had these pre-1600s lava flow, then you probably have a lot of very fertile, very arable land in that surrounding area. Okay, then we have 1600s to 1980 lava. There we go. Now you can say hello, Loki. There we go. See, this is the menace who's been tormenting me and trying to get me to play with it. So Loki, say hi. There we go. You want to sit? You want to sit? Sit. Here you go. Good boy. You can stay here now. Cool. You can stay here. Okay. Lessons given by Loki. And now? Hello. Right, so then I was looking at the orange areas. So then 1600 to 1980, we don't have as much as the pink. So we have these areas flowing there and there. And this is 1981. So this is the most recent until that study. And that's the red. Okay, pyroclastic cones and eruptive fissures. So those lines that are crisscrossing over the whole thing is where there are weak points and where there have been eruptions. Where there are weak points and there have been eruptions. And pyroclastic cones. Oh, I see. There's these little dots at the end of all of the lines. So there must have been lava that's probably come out from those weak points, from those fissures, and it formed some type of dome, so maybe kind of like lava domes, I would assume. Oh, and I see all of the blue surrounding area is sedimentary rock. Okay, so then we would have this layer of like igneous resistant rock over the softer sedimentary rock, and that is where a lot of other landform features originate from. But we can at the very least see how many urban settlements are in the surrounding area. The level of alert was raised at the airport, but no immediate interruptions were reported. Okay, so it looks like the ash cloud had cleared by that afternoon, and it doesn't seem like there was actual interruptions to air travel, although that must have been an incredible thing to see. Look at all of that ash, this massive plume of ash and dust and everything just going into the sky. And then obviously how the wind blows and whatever the weather is doing at that time will influence how this is then spread out. Flights be affected by the eruption, and is the airport closed? Just close these. So the airport stands at the foot of the mountain, giving departing and arriving passengers a spectacular view of the volcano. Okay, Loki, do you mind? So the people, as they arrive in, they get to see the volcano. That's pretty cool. Okay, there's just been a few minor delays, so it doesn't really look like they've closed down anything. I have a very demanding puppy that is waiting for me to play with him. Well, then I hope that this video has been helpful. I hope that you at least enjoyed a cup of coffee and maybe you learned something new or had a few questions answered. And then I hope to see you guys again soon. Have a lovely day further. Cheers. Bye.